Hi, I'm Kian and welcome to my Smart Office Network Design project for Assessment Task 2 of the Preliminary Enterprise Computing course. In this video, I'll take you through how I designed and built an automated Smart Office using Cisco Packet Tracer and a variety of Internet of Things technologies. I will be covering the design purpose, how the devices I used were named, configured, and connected, the automation which was implemented, how innovative technologies have influenced IoT devices, and finally, the social, ethical, and legal implications of implementing this kind of system. The design purpose. Before we begin, what exactly is a smart office? A smart office is a workplace equipped with internet-connected devices that automate tasks such as lighting, temperature control, and security. These devices communicate with each other to improve comfort, safety, and efficiency in real time. The goal of my smart office network is to create an intelligent, energy-efficient, and secure workplace by automating everyday operations. This enhances productivity, improves staff comfort, and reduces the environmental impact. In my smart office network design, the layout is divided into 4 main zones, areas 1 through to 4. This is based on the Cartesian plane's quadrants, which increase in number as we move anti-clockwise. My layout consists of a reception area, an executive office, an IT room, a storage room, 3 toilets, a lunchroom, an office, and a conference room. Each room in my smart office uses IoT devices that connect wirelessly and perform automated tasks. To make the network easy to manage, I followed a consistent naming format. Room abbreviation, underscore, device type, and a number. The number is only used if there are more than one of the same device. For example, the lunchroom will be abbreviated as LR, and its 2 lights will be LR underscore light 1 and LR underscore light 2. Toilet 3's humidifier would similarly be named T3 underscore humidifier. Now there are 2 ways to rename a device. The first way is to first click on the device and go to the Config tab. Here, we can click Settings and then edit the display name. The second way to change the name is to simply click directly on the device label below the icon to edit it. Now that the devices are named, the next step was to configure the central server, which handles the IP addressing. Here, I clicked on the server, then opened the desktop tab and pressed IP configuration. I then set the IP address to static, then manually entered the IPv4 address and subnet mask I had planned earlier. This is so that all the client devices in my network have consistent and reliable access for connectivity. I set up DHCP so all other devices receive their IPs automatically. This is because they're all connected to the server, and this reduces the setup time across the network and supports network scalability. To do this, I simply swapped over to the Services tab and clicked DHCP. I then ensured that the service was turned on. I then entered the starting IP address, the subnet mask, and the maximum amount of users. After checking that all the settings are correct, I clicked Save so the DHCP would be updated and activated in real time across my network. To manage the IoT devices, I used a remote server. I firstly opened the server and went to the Services tab. Here, I clicked on IoT and ensured that the service was on. This step is essential because without it, the devices won't be able to connect. Then, under the Desktop tab, I entered the IoT monitor. Once this has loaded, I entered the server's IP address and admin credentials, which I had previously configured. This allows me to enter the IoT monitor dashboard. It lets me view and manage all the smart devices in one place, as we can see, as well as the setup conditions for automation, which I'll explain later in this video. The next step is to connect the IoT devices. Each area has a wireless access point and a switch for devices to connect to. For example, in Area 2, the access point is named A2_ABT, and the switch is labeled A2_switch. To configure the access point, I firstly went to the config tab, port 1, and set the SSID to area 2. I then turned on WPA2 password encryption for security and set the password to area2_network. The numbers for both will correspondingly be changed across each area, such as area3_network for area 3, clearly distinguishing it from other SSIDs across the network, avoiding overlaps. Then, I manually configured these settings into each device. For example, I first clicked onto the motion detector, went to the config tab, and into wireless 0. I then manually entered the SSID and password into each of these, which are area 2 and area2_network respectively. I then toggled between static and DHCP to request a new IP address from the server. I then confirmed the device was connected by checking for a valid IP address, which should be in range from what we had configured in the server before. The connectivity is also shown by the dashed wireless lines, which are connected to the access point, as we can see here. There are two ways in which we can configure a PC, and it is slightly different from other devices. The first way to do this is through a wired connection. I firstly added a PC onto the desk of Office 1 from the End Devices tab and renamed it 01_PC. Here, I went to the Connections tab and selected a copper string for cable. I connected this to the PC's fast Ethernet 0 port and then to an available port on the local switch. Once you can see green triangles on both ends, this is how I knew that the link was indeed active. For wireless, it was slightly more complicated. I dragged another PC onto the desk and renamed it 01_PC2. I then clicked onto the PC, went to the physical tab and powered the PC off. I then replaced its current module with a WMP300N wireless adapter, which allows it to connect to a wireless network. I then powered it back on. After this, I went to the desktop tab and PC wireless. Here, I clicked connect and pressed refresh. This refreshes the network list. Because we are in area 4, I simply connected to that network. Here, I entered the pre-shared key, which was also the WPA2 password, which is configured into the access point. Once connected, you can see in the bottom right that the adapter is now active, confirming the connection. I then went to IP configuration and toggled to static and back to DHCP in order to request a fresh IP address from the server. Once confirming that the DHCP request was successful, I also checked that the PC had now appeared wirelessly linked on the screen via the series of dashed lines. This confirmed that the connection was now active and secure. Each room's access point connects via a copper straight-through cable to its local switch. These switches then connect via the same cables to two core switches in the IT room, labeled IT_switch main and IT_switch backup. This is for redundancy, where if one switch fails, the network keeps working and will not be disrupted. Both core switches then connect to IT_switch distribution, which links to the central server, as the server only has one available port. This setup improves reliability and scalability, allowing the office to expand without difficulty while decreasing the risk of network failure. As seen in this simulation, my devices are organized in a star topology, where each device connects to a central access point. This allows for easier management and scalability, where if one device or connection fails, it will not bring the entire network down. To connect everything to the internet, I firstly connected the cable modem from the main internet source to the distribution switch via a copper straight-through cable. This allows for the internet to be connected to the switches and hence the server. I also linked the main and backup switches to a wireless router. This router provides internet to the entire smart office, as all the switches in the office are connected to these, allowing for real-time automation, external communication, and remote management. All wireless connections use WPA2 password encryption, securing the network from unauthorized access and maintaining data privacy. Now that we understand all the configuration steps, let's go through one example. In the conference room in Area 4, I added a motion detector by the door. I then renamed this to CR_motion detector. I then open up the detector settings, went to its config page, and then wireless 0. Here, I enter the SSID, which is area 4, and its respective password, which is area 4_network. I then toggled between static and DHCP in the IP configuration section in order to request a new and in-range IP address from the server. After confirming this, I went to settings and switched the IoT server to the remote server. I then entered the server address and login credentials. I then clicked connect. Once connected, we can see that the connect button has switched to refresh. I also checked that the connection was active via the series of dashed lines between the motion detector and the access point, which we can see here. Let's move on to automation, one of the crucial aspects in smart offices. Using the IoT monitor, I created conditions for a variety of IoT devices and for multiple purposes. The one I'm going to show you, I want the lights to turn on when motion is detected in the conference room. I opened the IoT monitor and created an automation. To do this, I clicked add in the bottom left corner and named it CR_enter. I then set the if statement to be if motion detector equals true, because we only want the lights turning on if the motion detector detects motion. After finding respective devices, I then set the then statement to be then set CR_light1 and CR_light2 to be on. After I have done this, I press OK. This means lights turn on automatically when somebody enters the conference room. We can simulate this here by hovering my mouse over the motion detector, where by detecting this movement, it should turn red and both lights will turn on. So let's give it a shot. And yes, both lights do turn on. This improves both energy efficiency and comfort. It is also important to create a counter condition, which essentially turns the lights off when nobody is in the room in order to reduce energy waste. Other examples include humidity sensors activating humidifiers and smoke detectors activating sirens for safety. This condition is different because I use the match any rather than the match all, which means that if any of these if conditions are met, then all the respective then statements will be carried out, improving safety in the smart office. Altogether, automation enhances the office to become more adaptive, responsive, and efficient. Several innovative technologies have made this smart office possible, each playing a key role in how IoT devices function in the real world. To begin with, cloud integration is a major innovation. It allows me to monitor and control all IoT devices in real time from anywhere through tools such as the IoT monitor. This means that automation rules can be managed remotely, device statuses can be updated in real time, and alerts can be received instantly, all which wouldn't be possible without cloud-based services. Another example is the use of wireless modules, such as the WPA2-PSK wireless adapter. These allow devices to connect without physical cabling, making the network easier to scale across multiple areas while reducing clutter. This means that devices can join the network from any location within range, which makes it easier for IoT devices, such as sensors, to be installed across rooms. This wireless flexibility has revolutionized how devices connect, and is a crucial aspect for creating efficient, scalable, and automated environments. Finally, I use WPA2-PSK Encryption, which allows me to secure wireless data from outside threats. While this has been around for a while, it still remains as a crucial innovation in securing wireless networks, especially in environments where IoT devices are constantly transmitting data, such as in my smart office network. This encryption protects against external threats and prevents unauthorized access while ensuring both privacy and network security. Together, these innovations make the network scalable, flexible, and secure, all of which are essential to a smart office. Smart offices come with many responsibilities, and we must consider the many social, ethical, and legal implications on the individual, society, and the environment. Socially, my smart office enhances accessibility, especially for people with disabilities. This is because the utilization of automation through devices such as motion detectors automatically switching on lights, it improves the ease of use and accessibility. This has a positive impact on individuals. My smart office also supports the environment through automation. For example, if somebody exits the toilet, I created a condition for the lights to turn off. This not only improves efficiency, but also benefits the environment as it reduces unnecessary energy consumption. However, increased reliance on smart systems may hinder social interaction and reduce face-to-face connections. This can also create an isolated society and hence a disconnection to nature. Another concern is the digital divide, where not all staff may be tech literate and have access to technology. This can hence limit their employment opportunities and create disadvantages in society. Ethically, there are many concerns which may arise, and users should always be informed about what data is being collected and how it's used. For example, my smart office utilizes motion sensors and cameras that are constantly active. The system should only collect what's necessary for automation. However, if it was stored, it could breach Australian privacy principles. Respecting privacy and clear communication builds trust within the society and avoids misuse, setting a positive example for other workspaces or future implementations. However, there are also positive implications. For example, by switching to online databases and using digital tools such as online whiteboards, it reduces paper usage and helps to preserve trees, ultimately benefiting the environment. In Australia, smart offices must follow the Privacy Act 1988, which includes the Australian privacy principles. This means that it must store personal information securely, limit access, and protect data. I've made sure that only authorized users can access sensitive systems using specific access controls. For example, I've done this through wireless connections being secured with WPA2-PSK Encryption, in order to prevent data breaches and protect an individual's information. On a broader scale, this also helps to maintain public trust and follow societal standards. Australia also has e-waste legislations, with key aspects including the banning of e-waste in landfills. This is relevant because in a smart office, there are many devices which may be disposed of due to new updates, and careless disposal can lead to pollution. I must be sure to consider responsible e-waste practices to help reduce pollution and minimize negative environmental impact. To sum up, I created a secure, reliable, and scalable smart office using IoT devices and Cisco Packet Tracer. In this video, I went through a consistent naming and structured configuration, how to connect devices both wired and wirelessly, redundancy by star topology, and real-time automation through sensors, actuators, and conditions. I also discussed how innovative technologies have influenced IoT devices and considered the social, ethical, and legal responsibilities. This project reflects how IoT can transform offices into responsive, efficient, and automated environments. Thanks for watching, and I hope this has given you a clear understanding of how a real smart office works. Until next time.